Okay, so I'm Teacher Melai and let's talk about logical connectives. So in this topic, we are going to talk about the different logical connectives or sometimes it is also called operators. So when two or more propositions are combined, we use logical connectives or that's are actually called compound propositions. So when we combine two or more propositions, we call that as compound propositions and we connect it using connectives or operators. And some common connectives are negation, conjunction, and disjunction. So in this video, we are going to talk about these three connectives or operators. So this is the truth table of our negation. So as discussed in our earlier topic or in topic when we define what is a proposition, so we said that it is a stated in a declarative statement that it can either be true or false. So since we can identify whether the statement is true or false, so how can we now determine also if our statement is still true or false after placing the connective? So the connectives here is the negation. So this is the symbol for negation. It is like a part of a box. If you're going to draw a box or a square, it is just a portion of the square. So this one. So this is called the negation symbol. So if the proposition, what is the meaning of this table? If the proposition is true, it means that if we add a negation, so that is a not P, it means that it is false. And if the proposition is false, and if we add again the negation not, then it is or it becomes true. And this is also the conjunction. So we use the symbol caret, this one, the one that we use when we raise something or when we do some exponential formula or equations. So given this two propositions, so we have the proposition P and proposition Q. So if the proposition is true, proposition P is true and proposition Q is true, then P we the caret here is read as end. So P and Q is equal to T. So the rule here is that if both statements or if both propositions are true, then P and Q is also true and all others are false. So this is this junction symbol. So it's a B. Sometimes they read it as PVQ. So it is actually P or Q. So in this rule or the rule in the true or false table is that, or the truth table rather, is that if the statements are both false, that is the time that P or Q is also false. So as you can see here, if it is true and true, the answer is true. T and F, it's T. F and T is T. F and F is T. So these are all the possible situations wherein we can identify what is the value of all possible values of P or Q because we just have two statements. What if, for instance, we have three statements, so P, Q, and R? So it means that this table will contain, so here we have 4 rows only. So which means for three propositions, we need actually 8 rows because the rule is that if we have two statements, we're going to use 2 raised to n, and n corresponds to the number of propositions. So for two propositions, it's 2 raised to 2, so we need 4 rows here to represent all possible conditions. While if we have 3, then we will present it as 8 because, for instance, we have 4 true and 4 false. So 2 times 2 times 2 is 8. So let's have an example.